Okay, so just I want you to keep in mind two important things that whenever you're constructing and interpreting confidence intervals. Please keep in mind that just like in the previous sections, we are assuming that our method of calculation assumes that the data comes from a simple random sample of size n from the population of interest. So this helps us to reduce bias and making sure that we can make inference to a larger population. Okay, and then the second thing is just make sure that you understand the margin of error in a confidence interval covers only chance variation due to random sampling or random assignment. And just keep in mind that when I say it covers chance due to random sampling. That's just like when you take different random samples, you're going to get different point estimates, which are different X bars or different pre-hats. That's chance variation. That's going to vary from sample to sample. It doesn't discuss the margin of error doesn't take into account if you did a convenient sample or a non-response sample or something like that. So that's why the simple random sample is really important. All right, so let's just take a look how we can construct a confidence interval from our simple random sample of 100 teenagers and discussing the mean number of movies. All right, so let's just put some mathy terms into our formula. So we know that our confidence interval is a statistic plus or minus the margin of error. The margin of error is the critical value times the standard deviation of the statistic. All right, so here's what we know. We know that the average of the 100 teenagers, or the mean of the 100 teenagers, is X bar. That was 2.1. They go to the movies 2.1 times in a month. Now, the critical value here, this critical z-score, depends on our confidence level, and our confidence level in this case is 95%. So that basically means we want to take up 95% of the curve, and we're going to have 95% is going to be the confidence interval, and then 5% is going to be outside the confidence interval above and outside the confidence interval below. Okay, and then the standard deviation of the statistic, since we're talking about sampling means, is the population standard deviation divided by the square root of n. And we were given that the population standard deviation was 0.5 divided by the square root of 100. So notice how it's plus or minus, so we're adding the margin of error and subtracting the margin of error. Why do we do that? Remember, that allows us some wiggle room that says, okay, we're not going to, 2.1 might not be exactly correct, but the true population mean could be somewhere within the specific interval. So, and there's your final answer. Now, always make sure, don't just write this as your final answer. We actually want to see what that confidence interval is. We actually want to see what the average amount of movies that teenagers go to in a month. So make sure you write your final answer as number, comma, number. I actually have this, so right here we have 2.198 to 2.002. Okay, and that didn't really change that much. Actually, these should be written the other way. So the lower number should be first and the higher number should be second. Okay, so when we're taking a look at our confidence interval, what do we need in order to construct the confidence interval? So let's see what we're talking about here. Number one, we're talking about sampling means. So we are actually using the sampling distribution of sample means in order to construct our confidence interval. So when we're talking about that normal curve that we got our critical z-score from, it's from the sampling distribution of taking 100 teenagers, finding the mean number of movies, taking 100 teenagers, finding the mean number of movies, doing that over and over and over and over and over again. Okay, so that means in order to use this critical z-score and the standard deviation, we have to meet some conditions the same way that we did in the previous unit. Well, what were the conditions in order for using normal calculations for sampling means? Well, number one, it still has to be a simple random sample. Number two, we have to know the population standard deviation in this case. It will most likely be given to you. And number three is we need to find the standard deviation. So in order to do our standard deviation calculation, the population still must be more than 10 times the sample size, okay? And then we're also going to get into, we have to make sure that this is approximately normal. So in this case, we know it is because the central limit theorem tells us if our samples are bigger than 30, then the normal curve that we construct from all of those samples, or the curve that we construct from all those samples, will be approximately normally distributed. Okay, so what are some goals for our confidence intervals? Number one, we would like to have a high confidence and a small margin of error. So when we say a small margin of error, we say we want to hit that mark of where that true population mean or proportion could lie. A higher confidence level, so what does that mean? That means that a higher percentage of all the samples produce a statistic close to the true value of the parameter. So a high level of confidence just means that when I take many samples, I want a lot of those samples to capture the true population mean. I want a lot of those samples to be close to the true population mean or proportion. A smaller margin of error allows us to get closer to the true value, so we want a small margin of error, because remember, we're using this confidence interval to estimate what the true population mean or proportion is, because we don't know what it is. So since we're using it to estimate the true population mean or proportion, we want a small margin of error to get us closer to what the true value actually is. So how can we reduce that margin of error? Number one, we can lower our confidence level. Okay, but then remember, that also means that we're not capturing the population mean or proportion as much of the time. We can lower the standard deviation. That's not necessarily realistic. And we can increase the sample size. So because remember, with our formula, our sample size right here is, our sample size is n. If we make a larger sample size, then that makes the denominator larger. It's going to make this portion smaller, so then it's going to make our whole margin of error smaller. If we have a smaller confidence level, this critical z-score is going to be smaller because it's not taking up as much of the normal curve. Therefore, this whole portion right here is going to be smaller. All right, so how do we exactly choose the sample size? So we can have a high confidence and a small margin of error if we choose the right sample size. So that means we're using a large confidence level, like 95, 99, 97, and that's what we want. Our goal is a high confidence. In order to get that and have a small margin of error, you have to have a sample size that makes that denominator, large enough and makes this portion small enough so that I have a small margin of error. We can determine the sample size that will yield a confidence interval for a population mean with a specified margin of error. So basically what we could say is we can say, okay, well, I know how big I want my margin of error to be. In order to get that size of margin of error, how large does my sample size need to be? So using this portion of the formula, okay, if we know our margin of error, we can fill in the critical z-score, the standard deviation, and the margin of error, and then just solve for the sample size. Okay, remember that the critical z-score is going to change based on the confidence level, and the standard deviation of the statistic is going to change based on the standard deviation of the specific problem that we're talking about. All right, so of these formulas that we've sort of talked about in this section, what is on the AP exam formula sheet? Number one, the general formula for the AP for the confidence interval is on the formula sheet. Your statistic plus or minus your critical value times the standard deviation of the statistic. You will just have to decide, A, what is your critical value? So you'll have to know how to find that and understand that's a critical z, and we're going to be learning about critical t's later on. And how do you find the standard deviation of the statistic? Because remember, it's different for sample proportions and sample means. But notice, look down here, okay, we have the sample mean, the standard deviation of the statistic, plug that in. Sample proportion, we have the standard deviation of that statistic, we can plug that in. All right, so let's just go ahead and try a couple examples. So according to the Gallup poll on August 13th, 2010, the 95% confidence interval for the true proportion of Americans who supported the job that Barack Obama was doing as president was the following confidence interval. Number one, we're going to interpret the confidence interval and level. Okay, take a minute and go back and look at the template. This has to be an exact interpretation in context. Please make sure that you do that. What is the point estimate that was used to create the interval? So think about what the point estimate is. What's the margin of error? And then a reporter claims that the majority of Americans approve the job that Barack Obama was doing. We're going to use the confidence interval to evaluate the claim. Let's go ahead, take a minute and try that, and then look on the next page. Okay, so here's our confidence interval. We just did the calculations right here. Now, remember, the confidence interval is an interpretation of what the interval means. And you will have to do this every single time you construct a confidence interval. With a confidence level, you only have to give this interpretation if it's asked for. So confidence interval, we are 95% confident that the interval from 0.41 to 0.47 captures the true proportion of Americans that approve the job that Barack Obama was doing as president. So 95% confident means that if we were to produce 100 samples, 95 of them would capture the true population mean. It's not a probability, it's not it's not a 95% probability, it's not a 95% chance, okay? The only time, I'm going to talk about this later down here, don't use the word between. You will see the word between, I just don't want you to use it to get used to it. So we can say we're 95% confident that between the numbers 0.41 and 0.47 captures the true proportion of Americans, but just sort of be wary of the word between. Okay, so, but I'll talk about that in a second. So the confidence level, remember that is discussing the process that we used in order to get the answer. All right, the process that we used. So if many, many samples of Americans were taking, the resulting confidence interval would capture the true proportion of all Americans who approved the job that Barack Obama was doing as president for 95% of those samples. So the interval is specifically discussing the interval. The level is saying, okay, if I do this many, many, many times, then 95% of the resulting intervals are going to capture the true proportion. That's discussing the method that we're using to find the confidence interval. Just avoid the word between, so don't say we're 95% confident that the true mean is between these two numbers. And the reason that you don't want to say it's between those two numbers is because it's not necessarily between those two numbers. That interval captures it, because whenever you do a second confidence interval, if you were to do a different poll, then these numbers are going to change. So it's not that the true proportion or mean is always going to fall between two specific numbers, because every confidence interval that you get is going to be a little bit different. So how can we say that the true mean or proportion is between two numbers that are changing every single time? That's not necessarily true. The interval is either going to capture the true mean or it's not going to capture it. Okay, so it's either like a 0 or 100% chance. It's either a yes or a no. Okay, also make sure you don't state it's the probability that it will fall in the interval, because it's not. We're creating an interval that's either going to capture it or not capture it. So it's either 0% chance or 100% chance. It's not a 95% chance that it's going to fall in the interval. It's our methods that we use. We're 95% confident that the methods that we use will capture the true mean. And then make sure you include the level, 95%, 80%, whatever, and then make sure you're using the correct wording with proportions or means. Okay, so what was the point estimate? So how do we get the point estimate? So your point estimate is always this number right here. Okay, it's the 0.44. It's the statistic from our sample. So it's always the middle of your confidence interval. If you ever want to find it, add the two ends and divide by 2. So your margin of error in this case was 0.03. That's a pretty small margin of error. Now let's take a look at that last question. So when you have this confidence interval from 0.41 to 0.47, that's basically like saying any number, any proportion between those two numbers is a possible value for the population proportion of Americans that approved the job that Barack Obama was doing. What does majority mean? Majority means more than 50%. Now, so if the true population proportion lies in this interval, 50% is not in the interval, so we can say that there's not really good evidence that more than 50% of the Americans approved the job that he was doing. Okay. All right, so let's just take a look at how we can find the 80%, 85%, and 95% confidence interval for example 2. All right, adjustments to machines sometimes change the mean length of the parts it makes. However, the adjustments do not affect the variability of the lengths. The lengths are known to be normally distributed with a standard deviation of 0.5, and after a series of adjustments, the following lengths were obtained for the randomly selected parts. So we're going to find these 3 confidence intervals. Okay. Now, number 1, before you do anything, okay, please, please, please find your critical z-scores. All right. So remember, your confidence interval is your point estimate. That's the sample statistic times your critical z-score times the standard deviation of your statistic. All right, so when you add all these up and find the sample mean, it should be 75.92. Now, this is only taking up 80% of the curve. We only want 80% of the curve. So 80% of the curve, you're going to do inverse norm of 0.9, which gives you 1.28. And the reason that it looks like that is because if you think about it this way, okay, if I draw my curve, okay, here's 80%. This is the portion that that takes up for my confidence interval, and I have 10% down here and 10% up here. So my critical z-score right here is sort of the portion, I sort of think of it as what separates what is the confidence interval and what is not.